So we're just past the hour, and uh, Ken's going to present some information about Mint. So, Ken,
Okay,
feel free to go.
thanks. I'd just like to thank the previous speakers. It's been a great afternoon, and it's given quite a lot to think about. So thanks, guys. Okay, this used to be a very wordy presentation, and then whilst I was waiting, I discovered PowerPoint Designer. And you might remember the early 1980s when everybody got a word processor and they used every font they possibly could. Well, I'm paying my homage to those distant days. So, okay, an introduction to Mint. Here's what I'm going to talk about. Going to look at the early work, going all the way back to Peter Dragono's Musis from 1969, which was a bytecode language to program early electronic synthesizers. And that ran on a PDP-8. And Peter Dragono went on to present to write a book on Mouse, which was in the early 1980s, which was a programming language running on the Z80, or also ported into Pascal. In the early 2000s, we had Tiny Fourth. Half a dozen years later, Ward Cunningham came up with this novel tiny interpreter that allowed you to exercise the I/O pins of an Arduino just using a single character commands. I then went on to extend that, and then I heard about Stable from Sandor Schneider. I really got involved in Mint properly about 4 years ago. John Hardy encouraged me to look at it for the Z80, and since then there's been other variants which I'll come on to later. You've all seen that. Okay, so Mint. It comes from the concatenation of the words minimal and interpreter. Like Forth, it's stack-based integer arithmetic, reverse Polish notation language. It uses two stacks, both a data stack and a return stack, but it uses single printable ASCII characters in order to express user definitions, variables, and primitives. Many of the symbols used and the syntax will be familiar to Forth users, but the big simplification, as well as it being not a full Forth, is that there's no dictionary, and user definitions and primitives are accessed solely using a jump table. So it provides a subset of Forth intended for lightweight or possibly resource-limited implementations. The source code is very compact, and I've done my best to make sure that it achieves a certain degree of human readability. What Rob was saying about having a sort of remote interface, well, you can do everything that you need with Mint with really just a serial terminal emulator. And you can just cut and paste the source text and edit it that way. So Mint is ideal for microcontrollers and microprocessors that are lacking in ROM and RAM. And one benchmark was the Mint interpreter on the Z80, which includes bit banging serial routines, will fit into the limitations of a 2K byte ROM. So moving on, here's just a summary of the history, the evolutionary path that I went through, the prehistory to what I now call Mint. I've mentioned some of the inspirations for it. I had to go at rewriting Ward Cunningham's text time, and I added maths, user definitions, and more variables. And I used that for a number of years for a simple control interface for motion systems. And I was working for a company that made force and torque sensors. And so I used it as a sort of hardware bring up tool. I also ported it to MSP 430 because I wanted a 16-bit target. And with that, I managed to create a memory dump and screen editor that worked using SPI RAM. Okay, so for the period from about 2013 to 2019, I ported Simple onto just about every platform that I came across. But it was still lacking proper stacks, but it could perform loops and conditional code. And of course, like Forth, there was the possibility to stack user definitions together so that you could form new functions. So about that time, I was out in California and I met Chen Hansen Ting, and he had been working on his eForth model for the MSP 430. So that gave me a bit of impetus to start looking at his eForth. Moving on, it was John Hardy with his talks about various threading methods for the Z80 that got me interested in porting it to Z80. I had a couple of RC 2014 dev boards, and they formed a useful platform. So in the spring of 2021, we were back into a lockdown, and I heard about Stable by Sander Schneider. Now, Sander had come up with the same sort of single ASCII character bytecode language, and he packed it into slightly fewer than 50 lines of very compact C. But what this did was it gave a formal implementation of how the stacks were used, and I found that very useful. I got chatting with John Hardy, and John and I discussed the possibility of adding the missing stacks and some more functionality, and putting it onto the Z80, specifically for the Z80 computer that John had developed nearly 40 years earlier, which was known as the Tech One, which featured in an Australian talking electronics magazine. So it was basically a hexadecimal keypad, 7 segment displays, and in the early 80s, it was limited to just 2K ROM and 2K RAM. So John and I worked together with Craig Jones, and we put together something that could be packed into the 2K ROM space of the Tech One, and provide a useful alternative to typing opcodes in hex, and a useful bit banging serial interface. So that was about 3.5 years ago. So here is the Tech One. I don't think the word ergonomics existed back in the early 80s. I wouldn't like to be left-handed using that machine. And here's the RC 2014, which gets the award for putting as few chips as possible on very small printed circuit boards. Anyway, moving on. Right, some of the implementation features of Mint. The virtual machine can readily be implemented on almost any CPU, and there are only 31 operations which we can think of being the equivalent of Forth primitives. There are also routines that support characters, strings, decimal and hex number inputs, and printing either by bit banging or by serial UART. There are 16-bit variables are defined by the lowercase characters A through to Z, and the user routines are defined by uppercase characters A through to Z. The familiar colon and semicolon notation for these definitions was borrowed directly from Forth. Memory access is with the familiar fetch and store characters, and there are special cases that are used to represent the stack pointer, return stack pointer, top of stack, and the top of the return register. Sorry, the return stack. The arithmetic and logic symbols are just what we'd expect, and hex numbers are preceded by the hash symbol. That, to me, that sort of reminds me of capital H. And then you've got your usual stack operations. Dupe is the double quote, drop is the single quote, swap is the dollar, which looks like an S, and over is the percentage symbol that looks like one thing over another. Now, the one character that we don't use is the slash, and the reason we keep that in reserve is that we intend to use that for extending the language. Okay, here is a a list of all the characters and the primitive functions that are available to us. I hope I've covered them all there. Sorry, just lost my mouse. Okay, so after we created Mint on the Z80, I was keen to show that it would work on other CPUs. So Alvaro did a port in 6502 assembly, which I'm hoping to use on my 40-year-old Acorn Electron when the post-apocalypse collapse project is required. Jason has written a generic version in C that's been tried on a wide range of processors. And he's also benchmarked a few of them for 1 million empty loops. The Z80 version, despite being written in assembling language, was really quite slow, at 275 clocks per loop iteration. If I go to the next table, these are the figures that Jason and I worked on together. The fastest one is at the top, which is the ARM 32H7 series, which not only is it 32-bit, but I think it's got a double execution unit in there, and that's why it achieves really quite extraordinary speed. Sorry, really quite extraordinary efficiency in executing the loop code. And then down towards the bottom, we've got the Arduino with the original ATmega328, and Jason was working with a variant of the 8052, which requires 12 clock pulses just to get out of bed in the morning. So that's why that's down there at the bottom. Okay, so more recent developments. I started taking an interest in Ting's E4th model again, which reduces the inner interpreter to just a subset of fourth primitives, 31 in total. And with these primitives, you can create a virtual machine, and then you can build a full fourth by combining these primitives and extend your application that way. So I noticed that Ting's choice of primitives are very close to those of Mint. And so I thought, well, if I find a way of defining Mint in terms of the E4th primitives, then we can use Mint to build a fourth using the E4th model. In this way, because a Mint primitive is defined only by one ASCII character and not a 16-bit jump address, certainly parts of the inline code is going to be a lot more compact than a conventional fourth threaded model. So an E4th build could be implemented in fewer bytes. Now, John Hardy's already written some of the more advanced Mint functions using inline Mint code on his Z80 implementation. So that sort of proves the concept that you can write higher level Mint using the Mint primitives. So thus, dare I call it, eMint could be a compact means to provide a portable code for a variety of different CPUs. So it could be said that eMint is kind of eForth's kid brother. Okay, so future work. Mint has acquired a small following with the Tech One community, who are mostly based out in Australia. John has recently, about 6 months ago, written an extended Z80 version that he's calling Mint X. And I'm slowly working towards a homebrew CPU design, either in 74 series logic or an FPGA that executes the Mint primitives as its native assembly language. So I'm calling that the Mint machine, and it's been inspired by James Bowman's J1 fourth CPU, and also the eForth work by Chen Hansen Ting. So a couple of observations. Mint has a very limited symbol set, so it'd be possible to use simple tool chains written in either Python or C to produce a cross assembler, which could be used to automate the build of Mint for many different MCUs or target processors. Additionally, Python could also be used to automate the assembly of Mint, converting a higher level language into a series of Mint primitives. So effectively a Mint scripting tool. And conversely, it could be used to decompress the compact form of Mint to a far less terse word set. So these are things that are currently under consideration at the moment. Okay, so the Mint machine, as I call it, it's 16-bit virtual machine. It executes Mint as its native assembly language. It's been influenced by James Bowman's J1 fourth CPU, and also the Ferranti F100L, which is a very little known 16-bit microprocessor manufactured in Manchester from 1976. And the reason I'm interested in the F100L is that it was put together with approximately 1,500 gates, which for any processor is quite an achievement. So as I've said a number of times, Mint is based on, the intended Mint instructions are based on Ting's eForth. Now, I've done a simulation of the Mint machine in about 100 lines of C code. And most of my simulations are done using the Arduino IDE, mainly because even though some people don't like Arduino, it's globally accessible to just about every hobbyist across a wide range of platforms. So, as I said, intended for implementation as a small soft core in a FPGA or as a very small 7.4 HC logic homebrew machine. And like I said, using a bit serial architecture like the Ferranti F100L, it could be implemented possibly in as few as 1,000 gates, and used for fairly slow processing, such as a smart SPI controller, or for other applications where serial at modest speeds is required. Okay, extending Mint. I said that the backslash character was retained as a means for extending the language. I had the idea that the backslash could be used as a tag similar to Chuck uses on his color forth. And using such a tag, it would allow longer word names to be put together, and also invoke the use of a dictionary search. So it's getting closer towards forth as we know it. Extending the word names to 2 characters would allow over 9,000 unique definitions. The backslash character could be used to code the following ASCII characters with bit 7 set, and on certain machines, bit 7 sets the character in inverse video. Here's the F100L, the Ferranti processor. Quite a big die, 5.8 by 5.8, but you can see the flip-flops that make up all the registers. Here's an annotated version of it. Right, here's a sample of Mint code that I'd now like to use as a demo, and then I'll be taking questions. And the demo will be done on my RC 2014 Z80 system. So here's the links and resources that I've already posted, and that, apart from the demo and questions, is the end of my presentation. Thank you. Okay, so somewhere I've got right. I need to share the terminal screen. Hopefully that. Do you have?
Yes, we see it.
Okay.
COM 18 Teraterm VT.
Right. Okay. Is it full screen for you?
Yes.
Okay. Well, if everything goes well, I can type a single character, and over the wonders of 115 keyboard, I can type some characters in massive font, and not just a one-trick pony. I can pick another character, and that should read, it seems to have been corrupted slightly. That should read banana bandana. Let's have a go with the Mint again. And then
yeah, that one, I think your screen,
your
screen is not wide enough. You would have to make the character rendering smaller.
Let me just knock the font size down. I had fun in games doing this earlier. It kept on using the wrong coding, so it came out as garbage. But let's try this now. No. Okay. So I can take some source code, and then within the terminal program, I can do a paste with carriage return, and here is my mint source, no pun intended, which I can paste in. That's it pasted in. So what we've got here, these are the backslash is used to, in this case, to denote it's a byte array, which are stored in at these lowercase variables. Now, this is actually the 5x7 coding for the letter A, the letter B, letter C, D, and so on. So it's possible to encode all of the blocky graphics. The G command is one that takes the bit from the array and either does \E is emit. It either emits the inverse space or the usual space. P is a command that works its way through the array and decides to print either of the two characters that it picks up from the G word. M is basically forming the printing of M plus I plus N plus T, and then a new line. And K is forming banana, bandana. And then finally, which I maybe haven't shown here, C should print mint, almost but not quite. And B, yeah, okay, demos are intended to fail, but I hope that gives you a gist of the mint system.
Good stuff. Thank you. That looks impressive. Everybody, questions, please. Don't be shy.
So I must emphasize that I'm not trying to recreate Forth here. I'm borrowing from a wide range of different inspirations and influences to make something that is a lot more compact than Forth. And one of the beauties about Mint with its virtual machine is that it can be implemented on virtually any processor. And once you've coded up the Mint interpreter into the native assembly language, you then have a virtual machine that will effectively use the same mnemonics for whichever machine you choose. So it sort of unifies the processors. So I grew up learning Z80 to the exclusion of 6502, but with Mint, once you've got the interpreter in each of those, you can write in the same mnemonics. And I will say that using modern tools like Python scripts and the rest of it, you can automate a lot of the writing of Mint. You don't have to keep all these symbols in your head.
Francois, go ahead, please.
Yes, Ken, I'm impressed, of course. This is as minimalist as it gets, but what is your biggest application using this environment?
Okay, well, I've said that I'm slowly working on a TTL homebrew computer, and I need to create my own instruction set for that. And so my thoughts is to tailor this TTL computer to the point where its instruction set and architecture is as close as possible to the Mint primitive set. And this means that in a similar way to James Bowman's J1 fourth CPU, this Mint machine will be able to execute Mint efficiently, more or less as its native set of opcodes. But
I understand that. My question was more geared towards software aspects, applications.
okay, well, sometimes you need a very small core processor included in an FPGA or whatever. And I think that Mint in about 1,000 gates could provide a very small core for maybe automating the handling of background tasks like UART and SPI communications, whilst the FPGA gets on with the heavy lifting parallel application. Basically, I'm quite lazy. I can write 2K of assembly language, but I don't want to write 6K. So that was one of my motivations.
You know, I'm at 8K and I'm still growing, and I don't feel ashamed of it to the least.
Well, what I will say, Francois, is that if you've never done any assembly before, I know a lot of us are well long in the tooth over assembly language programming, but for a newcomer writing a Mint assembler, a Mint interpreter on any microcontroller is a great way of learning the instruction set and architecture.
I'm sure it is. I'm sure it is. My point was, yes, you developed everything from the ground up, and that's great. That it is a fantastic achievement, but you need applications. At least something to make your platform look like it is sexy somehow.
Well, I will disclose the applications in a later video.
Come on, this is Forth. Nobody builds software with Forth. We just build Force, unless your name is Richard Wagner, apparently. So okay. I've actually been a fan of your Mint system for quite a while. I just think it's lovely and great and elegant. And I did several years ago. I played with it, and I found like really quickly when I'm trying to make software with it, like okay, I got to remember what the words do. And I thought about, and I'm curious if you ever thought about doing this, but I never got around to it. What about making another like dictionary map where you just have a table of the letters and then map text words to the letters and be it,
yeah, exactly.
Back and forth. So
yeah.
You can make a readable code.
Yeah, indeed. I fully agree. Basically, you type in something that is a little bit more verbose in terms of function names, word names, and then you run that through a Python kind of like a preprocessor that looks at what routines that you want and then allocates those routines to the limited number of reduced labels that you've got. So that's something that I've got in mind.
I was looking even just inside Mint itself, right? You just go down, you know, because you got a fixed array of what the possible words are. If it's a null there, then the word hasn't been utilized. When you declare a new word, just go find the first one that hasn't been utilized. You don't care what the character is. And
yeah,
all right, this is my next word. You
yeah,
do it all as like an outer interpreter for Mint.
Yeah, indeed. I was trying to keep it as simple as possible to understand, and I was also trying to reduce the overhead of dictionary searches and managed to reduce the jump table to just 128 jumps. So that can be done quite easily with an 8-bit processor. So I was trying to get the overhead of next as short as possible.
Certainly, in the spirit of being minimalist, Mint is really awesome. It's really powerful for the size of it. It's cool. It's a neat project.
Thank you for that. I appreciate being asked to speak about it. Okay, I think my time's up. Are there any more questions?
I don't think that's the case.
Okay, well, thank you, gentlemen. Much appreciate. Yeah, thanks, guys, for the feedback. I'll be hanging around a bit later if after the formal presentations, if we want to have a cafe type discussion. So that's all from me for the moment. Thank you.
Perfect. Thank you so much. That was really cool.